On Spotify, you can listen to all your favorite artists and podcasts in one place for free. You don't even need a premium account. Spotify has a huge catalog of podcasts on every topic, including ones you're listening to right now. On Spotify, you can follow your favorite podcasts so you never miss an episode. Premium users can download episodes to listen to offline wherever you are. Easily share what you're listening to with your friends on Instagram. If you haven't done so already, be sure to download the Spotify app. Search for ML on Spotify or podcast in your library tab. Also make sure to follow me so you never miss an episode of ML Machine Learning. I have noticed in my analytics that Spotify does host a lot of my podcasts, so I would recommend that you use it. Welcome to Machine Learning. This week has been real busy with deep learning. I did a couple of YouTubes where I explained some of the technologies of deep learning. One was with the MIST character set, and I was really pleased with the performance on that. I've done largely time series analysis with the deep learning and text classification, where I use the softmax on word embedding. But this was the first time I've actually done something with images, and I'm really excited because now I'm going to the next level, which is the convolution neural nets. And I haven't had a lot of success with the convolution neural nets, and largely because I hadn't had a really solid understanding of what the deep learning could do with just a dense network. And I was really amazed what the dense network was capable of. 97% accuracy. And when I looked at the images, I just randomly sampled a few images and then used those from my prediction and did a comparison against prediction versus test. And I was really amazed that how it was able to learn some of the characters. I mean, some of the characters were really terrible. I mean, they're very skewed. And this was from, I think, 70,000 images of handwritten characters and what it was. And so it learned all these different shapes, and it was able to abstract out the patterns. And so this deep learning, if you haven't got into it yet, you really need to, because it's amazing. And it's going into all different aspects of business and science and technology. And you can see why, because it can abstract. And the author of the book, Deep Learning with Python, Shalette, he says that deep learning is not based on the model of the brain. And so there's that was really revealing, because, I was trying to think how the brain works and relate that to deep learning, and I wasn't getting it. I just couldn't see how our perceptions and deep learning are the same. They're not. This is statistical learning. This is the way the machines learn, by statistics. But it was very interesting how he described each layer. He said each layer is really a filter. And so it creates these filters for inputs. So these inputs come through these filters, and then the filters then are used to make predictions. So you can get these filters of a lot of complex parameters and get these really high accuracy predictions of what it is. And so that's why, I believe that's why self-driving vehicles are so good, is if you think of the networks as filters or pipelines, and of different networks, and these different networks coming together to make decisions. It's a lot like the way the space shuttle worked, where it had a command module or unit, and it had subunits below it, and then based on the results of those subunits, the command unit made decisions. So I had a hierarchy. Now, if you remember, I think I talked about Whitehead, and I really should quote Whitehead a little bit more, but and also Bono, where it talked about that intelligence is really a series of dumb components that are gathering information. They're not making any decisions, they're just gathering information. And then you have these higher level units that are processing the information, or you could consider it as filters. So maybe, you have one that's doing text recognition, one that's doing voice recognition, one that's doing object recognition. All these things are coming together to give you different results, and then they are joined together, and based on those parameters, you could have discrete decisions or rules. You could even have a random forest with all these different rules and its trees to make a decision. And so then it's rule based, it's discrete, but at the lower levels they may be nonlinear problems that are being classified, and these networks are very accurate in doing their filtering. So I'm getting this different picture now of how complex neural nets really work, and becoming kind of interested in building a self-driving car. The challenge of the self-driving car really isn't that difficult. Your steering wheel turns a little bit to the left, a little bit to the right, but at the same time, while it's driving, it's making decisions like how fast to drive, and is it using, what are its indicators on what the speed limits are. Well, there's probably national grids that you can hook into through 8 RESTful APIs where it can connect to a satellite, make a call, get a based on its GPS coordinates, get a speed limit. So speed limit doesn't seem like that would be difficult. Now, when you're coming up to a stop sign, it needs to detect that the color is red, and that means to stop. It scans left, it scans right, and it begins its right-hand turn, accelerates to the speed, and then makes sure that the lanes are open. So there's this scripting that's going on that tells the self-driving vehicle what is safe to proceed, and really, and at that point, it's kind of like a video game, because now it's looking at where are the lanes and what are the possible lanes that it could navigate over towards its destination. So it has a destination, and then it's calculating what the possible routes to that destination are, and then it's making sure that it doesn't depart from the lanes. A lot of decisions that are going on in a self-driving vehicle. So you have a lot of teams working together, a lot of subsystems that have to be running and be tested. But yet, now there's a lot of level 3 autonomous vehicles. You still have to have driver assistance, but the goal of getting to level 5 is possible, and there's companies that are claiming that with the higher level of GPU processing that they can achieve a level 5. Now, I've been thinking about that GPU processing, because that's a major breakthrough in AI. Because if you run just on a CPU, it's very slow to do your training. You can't do large data sets, and for generative text, you're going to need very large data sets, gigabytes of data, or even terabytes, and it has to process through the algorithm through that, and it could take, with a GPU, it could take a week to run all the training. And so generative text is the advanced subject of machine learning and deep learning. And that's one that I think that if you're a PhD student, you need to seriously consider studying where natural language processing is, where generative text is, and begin to think about if there's new algorithms that could perform the mechanical reasoning better. So it learns from human reasoning, let's say human reasoning. Then you can do discrete reasoning where you can run algorithms that are discrete, and the deep learning could learn those discrete patterns. And then you could then take the deep learning and see how it responds to mechanical reasoning. And that's an area that I'm hoping that becomes more popular, is mechanical reasoning, because that's one of the problems with GPT-3 is that whenever they've exposed it to mechanical reasoning, it hasn't done very well. And the reasoning, and I think the main cause behind that is that either the algorithms are not capable of abstracting the mechanical reasoning rules, or they haven't figured out a way to train GPT-3 on mechanical reasoning. So either way, there needs to be some research done in that area, because that's a booming area. Natural language processing, because of the GPU and the power of deep learning, is becoming really popular. And I think NVIDIA is going to be right in there. Now, Google has its own chipset that it's built, but I think that's going to be more for the cloud, to keep its costs down on the cloud. I don't know if you can, as a consumer, buy a Google chip, or if that Google chip, how it's going to manifest itself in either in a PC, laptop, Android phone. But AI is definitely here, and it's going to be in everything. And understanding how that works is really important. Now, the reason that Keras was created is the author of Keras said he is to make deep learning available to everyone. And I think that's an exciting proposition, because, as I've stated before, if 85 million people are going to lose their jobs to AI in the future, then they need to learn AI itself so that they can maintain the AI, build more AI components that create better data automation, more areas that are automated, and that they can be part of that information transformation that's going on. So there was the Industrial Revolution, which goal was to basically put people to replace the human component of labor with machines. And so we saw lots of machines being created, but people were operating these machines. But eventually, instead of a whole floor of people doing work, you might have one operator and a machine doing the work. So that was the goal of the Industrial Revolution. Then it created a knowledge-based revolution, where everything was now moving to the knowledge-based worker, where his skills were very important. You had data scientists, data engineers, data machine learning, AI, deep learning specialists. So you had a lot of variation in these high-skilled labor jobs, where they were doing lots of data manipulation, transformation, and loading, and they were integrating deep lake, or large big data. Big data was being gathered and put into clusters, and lots of power was required to process billions of records. All right, those things still exist today, but they're more quiet. You don't hear about them as much. It's the buzzword for big data. IoT is surging up. We're gathering more information per device for IoT, and yet it seems very quiet. And so big companies are gathering more data. Your devices are gathering and transmitting more data, and so there's more data for analytics, and we're discovering more patterns in the world around us, where the information is becoming more accessible to us. We're starting to understand better chemistry. We don't know much about chemistry, really, and we think we know a lot because of all the science that's gone into chemistry. But what we've found out is we really don't know much about chemistry. We don't know much about biology. And we haven't really learned much about mathematics. It's like we've had 300 years of basically still being in the dark ages, where we learn little fragments of knowledge. But as far as the big picture, we don't understand much. And that was kind of Wolfram Alpha's argument for the new science, was that we've had very little progress in mathematics, and that more thought in mathematics needs to be applied. A lot of the math now is mechanical. It can be done by machines. The Wolfram Alpha, you can do integration, derivatives, differentials, all kinds of different plots. But interesting that all that existed, and then came Python. And Python is the huge language that's encapsulating everything. You can do graphics, you can do AI, you can do natural language processing, you can do computer games, build websites. Everything can be done in Python. And it's becoming more international, and so it's the fastest growing language in the world. So if you look at the most popular language in the world, and you ask yourself, how is it that, we can, just in the U.S. or in the world, just with 85 million people being displaced with work, how can they learn technology? And the answer is learn Python. Begin that today. Begin learning Python today. If you're just listening to this podcast now and you're wondering what the future is, it will be analytics. And so start analyzing everything. Analyze your work behaviors, analyze and plot your church attendance. Whatever type of human behavior you can gather data from, start analyzing it. Get a Raspberry Pi and start gathering data from IoT devices, and then controlling the Raspberry Pi with Python. Learn how to do RESTful calls. They're very easy. RESTful calls are not anything mysterious. They've been around with us for a long time. But recruiters have made it sound like that there's something mysterious. They put it on the resume. Must know RESTful. Learn these algorithms. The internet literally has millions of courses and components that you can learn from. It was interesting, even on Stack Overflow this year, I rose to within the top 200,000 of all the developers in the world. Okay, well, that's a long ways from claiming I'm in the top 1,000. But at the same time, I've got answered 414 questions, and it's in a wide variety of different subjects. And sometimes just on one day I'll just get like 2 positive thumbs up, and it pushes me up in the scoring. But see, the ones that are in the million range, that are in the top, they have 1 million points or so, I think what they somehow they have an algorithm to know where people are going to vote, give them a vote, because they're making like 450 votes, so they're making half of my vote count per day. So they have this huge production of vote counts that they're getting, and I'm not sure how they know where to go. And maybe the answer to that is, go where they go. So every answer they make, you shadow and make it the same answer. I don't know. But what I'm doing is I'm just kind of looking at what people around me have answered, and I've gone in and looked at their questions and answered some of them that have been interesting to me. So it keeps me, learning. I have to, I look at what I already know and say, how would I answer that question? And then I try to answer it. So who cares? Well, what I'm saying is that if you're trying to figure out and learn something, it's good to start solving problems. It's good to start writing code, figuring out better ways to write the code, how to encode things in a tighter manner, and then thinking about production. If you're going to be in a pipeline production, how do you maintain this code? How do you verify it? How do you validate it? How do you find balancing? How do you balance the data? How do you bootstrap the data? All these things should be things that, like little recipes that you have, that you understand and know how, and know why you do them. Like, why do you use a variance threshold on a deep learning network to do feature reduction? What is feature reduction? What is dimensional analysis with TSNE? What is PCA, principal component analysis? So, your mind gets going. It's like you become a kung fu master. You're thinking of a million things at once, and you're looking at one problem and thinking at it a million different ways. And that comes from experience and perception, and then constant practice. And that's what Stack Overflow is, in my mind, is constant practice. It's this desire to understand the world of ideas. And so you're looking at other people's problems, and how do you overlay the way you look at the world with their problems. And that's what Stack Overflow is, in my mind. Now, you've got the new component called Copilot that's coming out by Google or Microsoft on GitHub. Not sure yet how good that is, but it's still an impressive idea that you could have a code assistant. I imagine with Copilot that will become an integral component to Visual Studio and Visual Studio Code, so that you can you begin programming a particular component, and the computer at the same time could be running a parallel program where it's generating, based on what it's seeing you do, it's generating up a code set, and you're doing a comparative. So when you get done, it says, well, let's compare our code. This is what you did, this is what I did. And let's say the computer actually code is running more efficient, like you're doing SQL, and you write your SQL, and I'm doing a course on SQL optimization, so that's why I'm kind of picking on SQL. And you don't do you do your aggregations and your halving, and you don't do the subquerying, and then you run it, and the computer comes back and says, well, mine's like 30 times faster. And you go, well, okay, well, that's great. Let me see what you did. And then it shows you comparable code. It knows from your definition what you wanted, and then it uses that to get its definition, and then it uses subquerying, and then it uses that subquery to the halving. And then you see, then you could ask it, explain why yours is faster. Well, then it uses an NLP, and it does the summarization, and it does a translation from the SQL to natural language, and it generates up a text, and it tells you, because I used a subquery, and subqueries are faster because of the way the SQL is processed. It does the from first, and then it does the where, and it's creating this query one time and storing it in memory, and then it's referencing this subquery, and so you're not doing a record lookup on each one of the rows in the outer query. All right, well, that was a mouthful, but that's basically why the subquery optimization performs so much better. Is it was not doing queries per row, but it's doing a query one time and then doing the comparisons with each row in the outer query with the inner query, which has been queried only once. And that's acceptable. I mean, you can then accept, there is differences in performance. There is a big difference in the approach that you take with SQL in terms of getting performance. And those were big factors. Now, I've done a lot of aggregation, and I've done a lot of halving. In fact, I wrote one where I did the halving and I did the aggregation in the halving. And that sucker is slow, and it runs every day, and but back then I didn't think about using subqueries to improve performance and why that would give a better performing query. If I were to rewrite that SQL today, I would use subquery, and maybe I would use cross apply or outer apply because it makes it more readable. And having those and using that cross apply and outer apply, I think was Microsoft's way of encouraging you to use subqueries because they are faster and they do perform better. And I could have done something like that and then done my aggregation on my outer query and then using the results of the inner query do my comparisons on my halving. So those are things that you just kind of take for granted when you're coding about optimization. But knowing the strategy of the parser and then the SQL engine gives you huge clues into the way to approach your query. The same is going to be true with Stack Overflow and answering Python questions and machine learning questions. It's going to give you an idea of how to approach problems and how to think about problems. Because the machine assistant is going to be playing a bigger factor in the progress of coding. And so you're going to be using a lot more machine-generated code because it's going to be better quality. Machine-generated code is going to be better quality. It's like, why did fourth generation code generators overtake the ERP market? Well, why did they let them write in low-level Java? Because people make mistakes, and those mistakes can jeopardize the ERP. So rather than letting them jeopardize the ERP, they build code generators. And those code generators generated up C code, and they generated up from the DLLs, and they generated up Java code for the web server. So these were big improvements in the ERP world to safeguard their stability. And now we're looking at Python, this billions of Jupyter Labs and Jupyter Nodes files out there, and we're looking now at a next generation where it's possible that even with deep learning that you tell in natural language processing what you want it to do, and then the code generator will help you build your tensor structures and reshapes and get that into the form that it needs, and it will give you recommendations on the dense network. You'll run it one time, it'll look at the performance on that dense network, and it'll give you suggestions for new dense layers and abstractions and etc. So it could have kind of a recursive ability to look at the network, evaluate its performance, and then make adjustments to the network based on the data. So then, what your real job would be is to gather the data, and once you have that data, then work with the machine to create the network so that you're able to begin to make predictions. And, it will get to the point very soon because of the commercial startup companies that are now forming, that are racing to build platforms and get companies on subscriptions, that even in that market there will be a level of efficiency that can be still capitalized by open source. And so there's be open source platforms that you can begin to use, like Keras. Keras is kind of an API platform with lots of APIs for doing work. It could then move to more of a visual environment, more like H2O AI, where it's a visual environment where you're getting lots of graphs automatically, kind of like a Power BI, and you're moving things around in widgets. And so a widget approach to AI to build pipelines will be something that the open source world will move towards quickly. And so then you'll start to install that on Apache servers, and just like Spark, which I think Spark is a very good example of the future. I think it's going to be around for a long time. It will then become these big, huge cloud-based systems that are highly scalable with terms of hardware, with visual interfaces that you work with the AI and natural language processing to build AI pipelines. And so let's say, it takes, just by now, today, knowing code and the complexity of Keras, it takes you half a year to build a production pipeline. Then using the visual system, you could cut that down to 1 month. And then using Copilot with the visual system, you could cut that down to 1 day. You can see this huge acceleration in AI once we start getting tools and the machines start helping us in those tools to increase productivity. It's inevitable. And would you want to use code that's written by a machine? Absolutely, especially when it can verify that its efficiency is better, it is accomplishing the goals that you want. It's basically like trying to make the argument, should I use C or C++? I remember that day when my colleagues came to me and said, we did this challenge to write some computer graphics, and we were writing our graphics from the hardware level. So we were running the assembly and all that, and we were using C because that's kind of the next layer up. And these graphics were on 386 machines, and they were running fast. I mean, they looked really nice, and they were 3D, and we were doing our own polygon fits and all that, and it looked great. And we hadn't seen anything like this. We knew about Evans and Sutherland OpenGL, but we hadn't seen anything like this on the market. At the time, this was back in the early 90s, and we were really excited, about what we were building. We could have had 3D games before 3D games even were thought of, and missed opportunity because I didn't think about that everything needs to translate into dollars, and I didn't think about that. But yeah, we were building these 3D games. They weren't 2D games; they were 3D games, and they looked nice running on these 386 machines. So I had bought 386 machines, and I had a development team working to put things together, and things were going well. And I'm going to do this with AI. I had time to rethink about what the mistakes I made there and how I'm going to regroup and build AI. But what I'm getting at is every time period has opportunity. Don't worry about if you missed an opportunity. Every time period is going to have opportunity. Even 20 years from now, it may not be AI, deep learning, ML. It may be quantum computing. Quantum computing may have taken over everything by then. And now everything is, do you know how to do quantum computing? And then what goes beyond quantum computing? Maybe it's fabrication of things, fabrication of molecules, or some level of very sophisticated chemistry. Or maybe it's, quantum communication over long distances. But you don't know what the future entails. And even some of these ideas that I've read from books that have been talking about that since the early 90s, about what we're experiencing today. Today quantum computing is huge. We haven't seen it yet in a commercial environment, but I'm going to start doing some research on startup companies that are using the quantum computer. And what problems are they trying to solve? Material science, chemistry, biology. It's these areas that have really been weak because they don't have computational methods yet. And, one of the areas that is exciting, that's starting to have breakthroughs is pharmaceutical drug discovery using artificial intelligence. But see, they don't even use quantum computing. They're getting huge increases in productivity over traditional methods. And what would happen if you took AlphaFold and combined that with the quantum computing from IBM? Why isn't IBM working with Google to significantly improve disease discovery solutions in medicine? Why isn't IBM doing that? And be positioned to be the people who solve sickness throughout the world. So again, we don't know the why and what the motives are, but it's really amazing, when I think about the possibilities that you could end hunger in the world, that you could provide unlimited energy to 4 billion people at the bottom. You could provide AI to the poorest people in the world through natural language and voice to text, text to voice, general summarization. And now the rarity would be ideas. So as ideas then are thought, they can be materialized, they can be tested in simulation. AI then could help bring these ideas to people who could utilize resource to make it happen. That's one thing that Musk said, is he felt like, at Tesla, it was always starvation, he said. I said, why would he think it's always starvation? Not enough resources. He's always looking for more resources to build his ideas. And he's into all these different technologies, from space to electronic planes to cars. And he's trying to move things fast. But it's on that edge of chaos where all this innovation's occurring, this huge surge of innovation that he's creating. And he really is a rare individual in that sense. So my hat's off to him. And I think that what he's done is not evil. And I think that those type of things are interesting. I do find that his avoidance of hydrogen is a big mistake. I don't understand that one, but there is no infrastructure for hydrogen. There were better solutions for using water to create energy, but they were not allowed to materialize. So I could see this whole fear of moving towards an unlimited power source, and being left to deal with batteries and the limitations of those lithium batteries. And you look at Lucid Air that's coming in with its air battery, and 500-mile range, and it's going to be really popular in competition against the Tesla. But Tesla's been really smart. I hope that with the introduction of the Tesla truck that they don't go with the triangular looking shape, but that that's just one product line that if you really, really like that, you're going to get it. It's because they're going to have something that looks more like the Badger, and it's going to need to look like the Badger or the Raptor or the F-150. Super popular trucks. They need to compete in terms of style and look with some of these very popular trucks, because the competition is coming in. There's at least 10 electric trucks that are coming out. The Riv, the Badger, the Hummer EV, with its 1,000 horsepower, 500-mile range. You've got Rivian. You have Ford. Ford's going to be huge with its EV Lightning. I like that Lightning. It's it's coming in at $45,000, $50,000, so it's like a regular truck price. It's going to have the horsepower that you need for pulling, and it's going to have good acceleration. It'll have the F-150 look. It's going to be kind of a muscle truck. People like that, and it's going to be popular. That will be a very popular selling vehicle. So when Tesla releases its vehicle and Ford releases its vehicle, it's going to be a battle between those two, because once whoever gets that position will be the king. And my feeling is that Tesla will not have the triangular looking truck as its main go-to, but it's going to surprise everyone with a really nice looking vehicle that, like it's Tesla cars that are stylish, and that's going to create this huge demand for Tesla. Plus, it's got the huge manufacturing base that it's already built, and it's continuing to build, and so Ford's going to have big problems on its hand with Tesla, in my opinion. And if Tesla doesn't react that way, then it'll give chance of Ford to catch up, and then they'll eventually catch up with Tesla and push them out of the market. So either way, there can only be three, and so my guess would be Ford, GM, Tesla right now. But there's Toyota that's looking on the horizon too with its solid-state batteries, and so they're going to start introducing their product lines to the consumer. So it'll be interesting to see who the top three will be.